This is Lab 5, Falling Slinky by Switches Minigati. So the purpose of this lab is to measure and predict the motion of a stretched Slinky being dropped from rest. Uh, we used mainly we used Newton's second law, which consists of two main formulas: uh, the velocity and position update formulas, where the final velocity is just the initial velocity plus the net force divided by the mass times time, and then the final position is just the initial position plus the average velocity times time. And so for this experiment, the force net is comprised of force gravity, drag force, and the force of the slinky, which is just a tension force. And so the gravitation force is just comprised of the mass times gravity, and in the negative direction, the drag force is just air resistance, which is negative b times the magnitude of the velocity squared, and then the slinky force is just tension. So the of the tracker video, um, the mass of the slinky is around 0.25 kilograms, and the initial position, it's close to, it starts pretty much at 0, roughly like 5.07 times negative 3, and then 1.19 times negative 2, and there is no initial velocity as it's dropped from rest. And so as you can see, it just gets dropped, and then the bottom of the slinky stays stationary, and then it drops after the tension force disappears. So this is just the variables that need to be set up: the mass of the ball, the position, the velocity. The delta time is 0.003 repeating because the slow motion video is around 300 FPS, and G is just 9.8, and yeah. So this the first while loop just for the stationary slinky, sort of, where the bottom of the slinky doesn't move, and that's because the tension force and the gravitation force are they're equal, so it would be in it'd be in equilibrium, and so the weight and tension both added up, they're just opposites of each other, so the net force is 0. Then the we have the velocity and position update formula coded in Glowscript, and then it just prints, and then it just, yeah. Then the second part of the Glowscript while loop code is just when the slinky is moving. And so here we actually have a drag force and a weight, and there's no tension force anymore because the slinky gets contracted fully. And so because of that, it actually starts falling. And so here's a position versus time graph of what the what actually happened, the blue being the glow script and the red being tracker. And so as you can see, it's almost closely similar.